functions, and the first one we're going to look at is going to be the straight line function. Now, most people don't want to look at this as a function. They call it an equation or whatever, but it's a function, and you need to look at it in depth because it's one of the most important functions. So the general equation for a straight line is y is equal to mx plus c. Here we need to understand that the m is the special property. So in this case, the m is the special property, and it's called the gradient. And the c is the y-intercept. So whenever you're looking at a straight line, you must know that there will be two numbers in the equation. Usually the number in front of the coefficient of x, which is the number in front of x, is called the gradient, and that is only if the coefficient of y is 1. And the number which is by itself, which does not have a variable, is called the intercept, and it's the y-intercept. The y-intercept is this is the y-axis. When we are looking at our graphs, this is the y-axis, this is the x-axis. The y-intercept is any point which, if the graph passes through, let's say this is a line and it passes through that point, this then becomes the y-intercept. So what you now need to do is, we now need to look at how, let's look at an equation. For instance, y is equal to 3x plus 5. Now this would mean that the gradient is equal to 3 and the y-intercept is equal to 5. So generally what happens is, when you are looking at this, to plot this, it's quite easy. You just need to, normally we don't use the gradient to plot the graph, but we normally just find the intercept. So that's the best thing about the straight line equation. So we are going to find the intercept. And the easiest intercept to find is going to be when x is equal to 0. When x is equal to 0, my function, which is y, is equal to 3, becomes 3x plus 5 will become y is equal to, if I substitute for 0 there, I'll get plus 5. So this is, now you get y is equal to 5. So that will give me a coordinate where x is equal to 0 and y is equal to 5. We'll come back to that a bit. Now let's look at the other intercept. The other intercept is when y is equal to 0. So when y is equal to 0, remember our equation, y is equal to 3x plus 5, and then you're going to make 0, your y is 0, 3x plus 5. The 5 now comes this side, becomes minus 5 is equal to 3x, and subsequently the x becomes minus 5 divided by the 3. This would give us the point minus 5 over 3 for x, and the y becomes 0. So sketching this graph would be quite easy. We draw our y-intercept, the y-axis, and our x-axis, and then we're going to mark Now we're going to mark, remember our y, when this point here is, remember we had 0 and 5. That's the y-intercept. And the other one was negative. This one, it was negative 5 over 3 and 0. So I'm going to mark 5 there. And this is negative. So this point is actually negative 5 over 3 and 0. So if I'm going to draw the graph, and this is because this is a straight line, we're going to use a ruler. I'm not using a ruler, so I'm just going to draw it with my free hand. But you would probably use a ruler because it's a straight line. So now that's how we sketch a straight line. Now let's look at a straight line as a function. If we want to look at a straight line as a function, let's write down f of x is equal to 2x minus 6. Now again, the gradient here is what? 2, and we've got our y-intercept is 6. So if I'm just going to draw this one because I need you to understand certain things about functions. So we've got our line there, that's our y-axis, our x-axis, and remember, if I am going to draw this graph, when x is equal to 0, I am going to get negative 6 there. There you go, negative 6. And also, if I make y is equal to 0, I will get 3 for x. So I'm pretty sure this will come here at 3. So my graph will look something like this. I've just done the procedure without showing the working, but if you want, you can try and do it by yourself. So that's my graph. Now, there are certain things that functions undergo, things like transformations, and what I would like us to understand is the types of transformations that functions undergo. And the first one I'm going to talk about is shift. Shift up or down. I'm just going to write down somewhere. Let's just start with shift up. So if I want the graph to shift up, I am simply going to take my function and I am going to add so there's my function. I'm going to, let's say I wanted my function to shift up. If I wanted to shift up 3 units, I would say plus 3 there, which means that I am adding to the whole function, which means that my graph will move up 3 units. Do you see what I'm saying? So in other words, this graph will not move down, but it will move up. So if it is going to move up 3 units, the minus 6 will move up to minus 3, and the 2 will become somewhere like 2 over 3. So my graph will then move up. Can you see how this graph will shift up like that? And just to further it, my new function will be f of, let's call it a different name, because remember we said it's a shift, so it's going to be h of x. Remember, h of x is my new function, and we got it by taking f of x and we added 3. So which means that h of x is that this whole, the function, the original one in green, plus the 3 which I added, which will give me 2x minus 3. That's the shift up. What about when we are shifting it down? Let's look at when we are shifting it down. So now here we're going to say down. So let's shift it down. So if I'm shifting it down, it means that I am also just going to subtract from here. Here I'm going to just say minus 4. In other words, I am moving the function down. And if I move the function down, it means that the minus 6 here will come to minus 10 because I'm shifting it, and the graph would basically look like something like this. Let me just extend my x-axis and my y-axis so that you can appreciate what's happening. There you go. Then obviously when this becomes minus 10, obviously this will come to 5. So when I sketch the graph, can you see that it will move down? It's below the original there. Can you see how it has moved from here, from here to there? Can you see it's moving down? If I look at my arrow here, the graph is moving down. So now let's go and look at what it does. Let's call this function let's call it p of x. P of x then will become, because we are moving f of x down by 4 units, it's f of x minus 4, like that. So which means that p of x will become f of x minus 4, which is 2x minus 10. And that's my new function. Now let's look at again so that's when we have looked at shifting down. Let's look at shifting left or right. Let's look at shifting to the left. So now we have to look at what happens to the graph when it's shifted to the left. So when you are shifting the function to the left, you are no longer going to use x. In this case now, this x here will not be x, but let's say we are shifting to the left 2 units. Let me just write 2 units there. This means if I'm shifting to the left, it means that this is going to be x, then plus, because I'm shifting it by 2 units, my x will become x plus 2, which means that even here I will no longer have f of x, I will now have f of x plus 2. So you are sort of like replacing x with x plus 2. So what you now get is, you are now going to get let's take our function m of x, I'm just going to call it m, is going to be f of x plus 2, like that. So which means that if m of x is equal to f of x plus 2, which means that I am now going to replace that so that I can have 2. Replacing the x with x plus 2 would mean that I've got plus 2 there, then minus 6 there. So this would mean that this graph is going to be 2x plus 4 minus 6, which is just 2x minus 2. So if I was to look at what would happen to the graph, again, this comes to minus 2, and if I work it out, this comes to 1, and the graph, if you are looking at the graph, would come somewhere here, passing through minus 2 and 1, and the shift is in this direction to the left. Can you see that? So can you see it is moving to the left? So that's a shift to the left. Let's go to a shift to the right. Now with a shift to the right, again with the right, you are now moving the graph. So with the shift to the right, let's say I want to move this function, I want to shift it it's a straight line function and I want to shift it to the right. Let's say I want to shift it 1 unit to the right. So for me to shift it 1 unit to the right, it means that my x will be replaced with x, in this case minus, because I'm shifting to the right. It's kind of difficult to try and think it out and rationalize it, but when you plot the graph, you realize that it has shifted to the right. So do not try to make a deduction from your common sense. It's not really common sense in this particular case. It's contrary to what one would believe. And then this would be f of x again. It's no longer f of x, it's f of x plus 1. So if I had my graph and I wanted to, I would call it w of x, which is my new function, is actually f of x minus 1, because I said I'm shifting it 1 unit to the right, so that let's just say 1 unit, so that people can understand why we're using 1. Okay? So it's 1 unit, and then obviously now the w will then become w x is equal to, replacing the x in there will be x minus 1 minus 6, and then this will give us again 2x minus 2 minus 6, which would give us 2x minus 8. So now if you try to plot this graph, let's see what happens. If I was to try to plot this graph, and remember this is the y-intercept, it will go to minus 8, and if this would go to 4. If the x-axis was there, it would go to 4, and my graph would be there. So can you see the graph is moving in this direction? It's moving to the right, even though I used a negative. Now, these are not the only transformations that a function can go through. There are just a few more that we need to look at, and in this case, now we must look at a reflection, which is one of the things that we are supposed to look at. In this case, a reflection is normally the inverse function. That is when let's look at the inverse function as our first reflection, because the others are quite easy. Y is equal to x. When we reflect on the line y is equal to x, then we are drawing the inverse function. So if we had our function f of x is equal to 2x minus 6, the inverse function, or the reflection on y is equal to x, or the reflection on y is equal to x. This is a reflection. Let's just write that it's a reflection. When you reflect on the line y is equal to x, you are drawing the inverse. So now how do we find that? Remember, when we say y is equal to x, means that we must swap. This f of x must become just x, and this 2, where there is x, you're now going to put y, which is the same as f of x. And because we are reflecting, that's how it's supposed to be written. That is how it's supposed to be written. You are just, whenever you are looking for the inverse, the first thing you do is you replace the f of x with x, and you replace the x with y. So now that I've done that, I can now proceed to find what x is. X plus 6, because the 6 will now move from here to there, which means it becomes positive, is equal to 2y, and then this is x plus 6 is equal to over 2, because there's a 2 there, we divide it by 2, and we get that. So in actual fact, my equation, if I wanted to look at it in the format of a straight line equation, would be y is equal to half x plus 3, where this is x divided by 2 is half of x, and 6 divided by 2 will give me 3. So this is the inverse function, so we have to show that it's the inverse function by putting that negative 1 as an exponent of it. So this is the inverse function. Some people can write it like this: f of x inverse is equal to half x plus 3. Do you see? So that's the inverse. And what are the implications of this on the graph? On the graph, when we are drawing the inverse, remember our function, the original function was f of x is equal to 2x minus 6. And our inverse, as we worked it out, let me just put the inverse in green, f of x prime, negative prime, like that, is equal to half x minus 3, plus 3, sorry. So if we were to plot this, let me plot the original. So remember the original, it was cutting at minus 6. I'll put my minus 6 there. And it was also cutting at 3. I'll put my 3 there. So the graph was like this. So that's a straight line for me. Now that was the original graph, which is f of x. Now let's look at what happened to the inverse graph. Now, if you are plotting the inverse graph without looking at the function, you could use the function, but I don't want to use the function now. I just want to show you how to do it. Can you see this minus 3 is a positive 3 on the x-axis? You transfer it and it becomes a positive 3 on the y-axis. And then this is a negative 6 on the x-axis. You transfer it so that it becomes a negative 6 on the y-axis. So this, then when you draw your graph now, you're going to get a graph. Let's draw it in green. There you go. This line is a reflection of that line. And let me show you where y is equal to x is. Y is equal to x is this line which passes through there. It sort of like make sure that it's a straight line. It's a line which passes through, and those two lines are reflected on that line. So in other words, this one here, this line is reflected on that line, and it goes to there. Can you see? So that's how we look at the inverse function, and the straight line is the easiest one to do this, and that's a reflection for the inverse function. Let's look at now. Let's look at the other transformations. They can be h of x is equal to negative f of x. This one, you just need to remember that this, because you are making the whole y negative, it means that any value of x which you had would give you a negative y. If it was giving you a positive y, it would give you a negative y. So let's look at our Cartesian plane, for instance. So if I had a point there, and this is 2, and this is 6, this is negative 6. So if I had a point 2, negative 6, which means the x gave me a negative 6, the original gave me. The minute I reflect it, it means that that point will become 2, positive 6. So in other words, we are reflecting on the x-axis. So this is, for this one, it's a reflection on x-axis. Now, let's move on again, and we look at the other one. In this one now, it's, let's call it h of x again, And if we say h of x is equal to f of minus x, now again on the Cartesian plane, if I had the same point here, now if this is 2 minus 6 again, if I make the x negative, giving me the same y, it means that it will be minus 2 for the same y, which is minus 6, and my point would come to this side, would come here, which means that this one is a reflection on the y-axis. Right. Now the last thing we're going to look at when we are looking at straight lines is the domain and the range. Now usually with straight lines, unless they tell you where it starts and ends, let's look at when you have been asked to just draw a straight line. There is our Cartesian plane, and if you draw a line and they didn't give you any conditions for that line, the range and the domain are values of x where the graph exists. So if you look at the x-axis, that line, if it keeps going, it will cover the whole of the x-axis. So it means that the domain is x is an element of real numbers. It can be any number on the x-axis. And the range also is the same. Y is an element of all real numbers, because all values of x, this line can cater for all value of x. So that's a bit of a summary in terms of the straight line. And remember, like I said, sometimes they can give you a straight line with conditions. So I think let's have one where there's a straight line, and this one has got conditions, and the condition is that it will start there at 8 and it will finish there at negative 4. And obviously maybe let's make this minus 3, and let's also make this 6. So if you look at this line, what happens is, with this line, its domain is all the x values where it exists. So let's look at its domain. Its domain in this case is x an element of, we are starting at, because here it's also including, so we're going to use square brackets, starting from 4, negative 4, and ending at 8, because they gave you a condition. Do you see? And the range is the same. Range starting, y is an element starting from negative 3 and ending at 6. And basically you need to understand the domain and range of a straight line. Okay.